Let's understand heat transfer in this video.
Have you noticed a metal spoon getting hot when its end is in fire? Or how a bonfire warms you even at a distance? These are everyday clues that heat moves from one place to another. And we call that heat transfer. Heat transfer happens because one region is hotter than another. And heat always flows from hot to cold. There are three simple ways heat moves. They are conduction, convection, and radiation. Let us start with conduction, the transfer of heat by direct contact between particles. Think of a metal rod with one end in flame. After a while, the other end becomes hot. This happens because fast-moving particles at the hot end collide with slower particles next to them and pass energy along. Metals are especially good at conduction because free electrons carry energy quickly through the metal. When you touch a metal at 5 degrees Celsius, it feels colder than wood at 5 degrees because heat flows faster into the metal. Now a useful formula idea. The heat transferred in time equals thermal conductivity times area times temperature difference divided by length multiplied by the time interval. Here thermal conductivity, called K, tells how well a material conducts heat, and a larger K means better conduction. Also, the rod example assumes steady state, where temperatures at each point do not change with time. Next is convection, which happens in liquids and gases when the fluid itself moves and carries heat. When a fluid is heated from below, it expands and becomes less dense, so it rises, and cooler, denser fluid sinks. This rising and sinking makes a continuous loop and moves heat around, like the air over land and sea. During the day, land heats faster than the sea. The warm air above land rises, and cooler air from the sea moves in as a sea breeze. At night, the land cools faster, and the flow reverses to make a land breeze. Convection also explains chimneys, kitchen smoke rising, and large patterns like trade winds. Trade winds form because warm air near the equator rises and moves toward the poles, then cools and returns toward the equator. Finally, we have radiation, the transfer of heat by electromagnetic waves without needing any medium. The sun heats the earth by radiation, and thermal radiation travels at the speed of light and can pass through vacuum. All objects above absolute zero emit thermal radiation, and hotter objects emit more and at shorter wavelengths. A perfect black body absorbs all incoming radiation and is a perfect emitter too. And a small cavity with a tiny opening makes a good black body. An important rule is Stefan-Boltzmann law, which says the rate of radiation depends on the fourth power of absolute temperature and on how well the surface emits. Wien's displacement law tells us the wavelength of maximum emission becomes shorter as temperature rises. So what do we learn from this? We learn that conduction moves heat by contact, convection moves heat by fluid motion, and radiation moves heat by waves. We also learn materials differ in thermal conductivity, and surfaces differ in how they absorb or emit radiation. Let us quickly remember, conduction is for solids, and convection for fluids, and bulk flow, and radiation needs no medium. These ideas explain many real situations, from cooking to weather and to how devices lose heat. Keep exploring these concepts with simple experiments and diagrams. They really help. Thanks for listening. Stay curious and keep practicing problems step by step. If you want more clear lessons and practice, do explore the EduRev platform for friendly explanations and questions.